3 points are chosen randomly and independently on a circle. What is the probability that all 3 pairwise distances between the points are less than the radius of the circle? So first, let's explain what it is that they are referring to in the question. You've got a circle, and you've got the center right there, and you've got these 3 points, and I will call them A, B, and C. They're saying that if you create distances between these points, so A to B, B to C, and A to C, all of these must be less than the radius. So this is the radius right here, like that. They want you to create a scenario where AB is less than R, which represents the radius, AC is less than R, and BC is less than R, like that. So in the end, they want you to figure out the probability of that happening. All 3 are less than R. So we have to do this with, I believe, 3 scenarios. So I'll go through each scenario one by one. So scenario number 1, and that is AB is less than R, and we will describe this case. So you've got a circle, and I've labeled A, and I've put B twice. Now, why have I put B twice? Well, because B can be on either side of A. That is not told in the question as to that it can only be on one side. So this is my radius, and I'll draw the radius going to the other B's as well. And now AB is this distance, and of course it's also that distance. Now we want AB to be less than R. Now R is this guy right here. AB will be exactly equal to R when this angle is 60 degrees. That angle is also 60 degrees. As you can see that, because that makes it an equilateral triangle. AB will be less than R when this angle is less than 60 degrees. So written out, AB is less than R when angle BOA is less than 60 degrees. So that means that from here to here, which is 120 degrees, is basically our range for the criteria to make AB less than R. So 120 over the full, complete 360 degrees is our probability of making AB less than R. So 1/3 takes care of this scenario right there. Now we move on to our second scenario, which is AC has to be less than R and BC has to be less than R. So this time I've drawn 2 circles because we've got to look at it in 2 different ways. The first is when we have A here and we've got B here, and C is somewhere in between. So C is, let's say, here. And now we can draw our distances. This is, of course, the radius, like that. And AC is here, and BC is right here. And this is R, and this is R. And in a very similar way, this is going to be 60 degrees in terms of our range. Because if you notice, if C is in the middle like that, AC will definitely be less than R, and BC will definitely be less than R. But if C comes out here, then BC will be much bigger than R. So as you can see, C has to be in that 60 degree confined space. So from this guy, we basically get a scenario of 60 degrees over 360, which is 1/6. 1/6 is basically the probability of this scenario and this criteria. Okay? But there's another way of drawing ACB, and I think that is the most challenging part of the question, and that is as follows. The other way of drawing C and B together is when A and B are on the exact same point, and C is on either side. It can be on this side or on that side. And when you have that scenario, you basically get the following. You get a line from the center till C and just one line to AB because A and B are on the same point. Now, very similarly to the first scenario up here, this angle has to be 60 degrees and this angle has to be 60 degrees. That is the only way that you can create the absolute boundary for where C can be. Because at this point, if you notice, very similar to before, this is the radius, this is the radius, this is the radius. And if CA is also equal to R and AC or BC is also equal to R, these basically become equilateral triangles. So C can be here, but it most likely will be here or here or here. It's got to be in a way so that the angle is less than 60. Very similar to over here, the angle, I'll write it here, COA has to be less than 60 in order for these conditions to be met. So this scenario gives you an additional probability. It gives you 120 over 360, and that's 1 over 3. Now, we can have this, or we can have this, 1 over 3. And in probability, if you have one or the other, you add them. So 1 over 6 plus 1 over 3. And we have to find the average probability. And how do you find the average probability? Well, just like any other average, you have to divide by 2. We added two numbers, you divide by 2. So this looks like 1 over 6 plus 3 over 6 is 1 over 6 plus 2 over 6, all over 2. So this looks like 3 over 6 over 2. Invert and multiply, and you'll get 3 over 12, which is 1/4. All right? So 1/4 is this scenario right here, scenario number 2, and 1/3 was the probability for scenario number 1. Now we want all these scenarios together. So this and this guy right here. If you have to combine with the and in a probability question, you multiply the probabilities. So we have to multiply 1/3 and 1/4 to get the final overall probability, and that gives you 1 over 12. So this is the answer to the question, and that would mean number 25 is D.